Imagine a computer capable of simulating the structure of a protein in seconds, optimizing complex transport networks instantly, or even creating new drugs in a matter of days. This isn't science fiction. It's the promise of quantum computing. And Microsoft is closer than ever to making it a reality. Today, we will explore in depth Microsoft's new quantum processor, its revolutionary technology, its possible applications, and, above all, the real implications that this innovation could have on our lives, from personalized medicine to advanced engineering, pharmacology, and biotechnology. To understand why this processor is revolutionary, we need to go over the basics. Traditional computers, like the ones you use every day, process information in bits, zeros or ones. It's a binary system, simple and efficient, but limited. Now, imagine that switch can not only be on or off, but also in an intermediate state or in both states at the same time. That's the power of the qubit. Thanks to quantum superposition, a qubit can represent multiple states simultaneously. This allows for parallel calculations on an immense scale. Then there is quantum entanglement, where physically separated qubits can behave as if they were connected. If you modify one, the other reacts instantly. Einstein called this spooky action at a distance. By combining these principles, quantum computing can solve problems that are impossible for classical computers, such as simulating complex molecules or cracking advanced cryptographic systems. Now let's get into the good stuff. Microsoft's new quantum processor. This processor is special because it uses topological qubits, a unique approach compared to the approaches of Google and IBM. But why does this matter? One of the biggest challenges of quantum computing is the instability of qubits. They are sensitive to the slightest change in the environment, temperature, vibrations, electromagnetic fields. Anything can make them collapse. It's like trying to keep a soap bubble intact in the middle of a storm. This is where topological qubits come in. Imagine that instead of that fragile bubble, you have a robust structure protected by invisible layers. Topological qubits use advanced mathematical principles to create more stable and error-resistant quantum states. Or what does this mean in practice? Greater precision in calculations, fewer errors, and the possibility of scaling quantum systems to large scales without losing stability. In addition, Microsoft has developed new materials that allow qubits to maintain their quantum coherence for longer, which is key to performing complex operations. And what results has it obtained? In initial tests, Microsoft's processor has run advanced quantum algorithms with a significantly lower error rate than its rivals. And this brings the idea of a functional and scalable quantum computer closer than ever. This is where things get interesting. Quantum computing has the potential to revolutionize entire industries, and we're not talking about decades away, but about changes that could come in just a few years. 1. Medicine and pharmacology. In the pharmaceutical industry, simulating molecules and proteins is a complex process that takes years and millions of dollars. With quantum computing, we could design personalized drugs in days, model how they interact with the body, and minimize side effects before they reach clinical trials. In oncology, for example, we could design specific therapies for each patient based on their genetic profile, truly creating personalized medicine. 2. Biotechnology and genetics. Biotechnology would also be dramatically boosted. With the ability to model complex biological structures in real time, we could speed up gene editing with CRISPR, create more precise synthetic organs, or even simulate the development of stem cells for regenerative therapies. 3. Engineering and energy. In engineering, quantum computing could optimize everything from urban transportation networks to the energy management of smart cities. It could also revolutionize the creation of new materials, such as room temperature superconductors or more efficient catalysts for producing clean energy. 4. Artificial intelligence. And of course, artificial intelligence. Machine learning algorithms running on quantum computers could process massive data sets in seconds, creating smarter and more efficient AIs. Practical example, quantum AI simulating chemical interactions in the creation of a new medicine. 5. Everyday life. But how does this translate to your everyday life? In the future, you could have access to instant medical diagnoses, hyper-accurate weather predictions, and nearly impenetrable digital security systems. You could even have virtual assistants with a much greater learning capacity than those of today. Of course, not everything is so simple. Quantum computing still faces enormous challenges. Error correction. Although topological qubits are more stable, thousands of physical qubits are still needed to form an error-free logical one. Extreme conditions. These systems operate near absolute zero, 273 degrees Celsius, which requires advanced cryogenics. Scalability. Going from tens to thousands of qubits without increasing the error rate remains an enormous technical challenge. Security and ethics. Quantum power could put current cryptography in jeopardy, generating a potential risk for global digital security. Quantum computing is no longer just a laboratory concept. With developments such as Microsoft's new quantum processor, we are ever closer to a technological tipping point. And although we are probably years away from having quantum computers in our homes, their influence on key sectors will be imminent. The big question is, are we ready for this leap? Can we handle the power of a technology that could rewrite medicine, biotechnology, global security, and even the economy? Is quantum computing the greatest advancement of our era, or a tool we don't fully understand yet? Leave your thoughts in the comments and subscribe to explore more about science, biotechnology, and the future of technology.